Today we are going to continue our study of Science Chapter 3, Cycles in Nature, with Lesson 2, which is Ecological Succession. You'll need your textbook, pages 80 to 83, and your directed reading. There are 3 objectives for today's lesson that you should be able to do by the end, and they are: describe the process of succession, contrast primary and secondary succession, and explain how mature communities develop. So take a look at these 2 images. The larger image is lava from a volcano, and of course the second image is also lava from a volcano, but you'll notice, and I know there's a color discrepancy here, but it's the same thing. But in the second image, you notice that there is a fern growing. Well, this is lava that has hardened after the volcano. So how did that fern get there? How is it growing? Do you think there's something special about the fern or the lava? Can other plants grow in little to no soil like this fern? In other words, what is going on in this image? Well, that is what we're going to talk about in today's lesson. It would be succession. So succession is simply the replacement of one type of community by another at a single place over a period of time. So the example of the regrowth of a forest after a forest fire would be succession. And if you'll think about here, a couple of years ago, we had the fires up in the mountains. Now they're undergoing succession. But you don't necessarily have to have a major disturbance like a forest fire in order to have succession, because succession takes place in all communities pretty much all the time. But we're going to learn about 2 specific types of succession today. Before we get into that, though, I want you to watch the following video. This is of a forest fire, and it's a controlled burn that is done to clear off the underbrush. And then you will see as it's a time lapse, so it's sped up, and you're going to see where things grow back. So as you saw there, that is an example of succession after a forest fire. And you can see that things grow back really well. We are now going to watch our study jam on changes in ecosystems that will tell us about primary and secondary succession.
I haven't been fishing since last summer. I'm so glad I hit you up to go. I had no idea you were into it.
Oh, totes, I love fishing, and the lake is always so pretty.
It usually is.
Ew, yeah. The lake is not looking so hot today. And it smells.
Read the sign. It's polluted.
Oh, it makes me so mad when people pollute. I wish they cared more about conservation.
It's crazy. People need to realize that their actions affect the environment and the ecosystem.
For reals, both people and nature affect the balance of an ecosystem. Ecosystems are constantly changing in small ways, like when new organisms grow in an ecosystem. There's a name for those changes. I just can't remember what it is.
It's called succession. Succession is when new organisms start to grow and live in an ecosystem.
Oh, right. And succession is gradual, so we don't notice them right away. See how the lake is covered in that gross green muck?
Yeah, it's everywhere.
Well, that muck is algae that started growing because of the pollution. Since it's a change that's happening to an ecosystem that already exists, it's called secondary succession. The ecosystem is already in full swing, so secondary succession usually happens faster than primary succession.
Exactly. Now, primary succession is the birth of an ecosystem and is the change that happens right at the very beginning when there's nothing but rock. It takes a while, but eventually that rock turns to soil. Plants begin to grow and an ecosystem is created.
Well, whether the change is primary or secondary, the ultimate goal of succession is for a complete ecosystem to exist.
It's the way ecosystems fight to survive. Fires can burn down forests, hurricanes can wipe out animals and plants. Even pollution like this can threaten to destroy an ecosystem.
Yeah, but with secondary succession, ecosystems can fight back, regenerate, and start over again.
I hope secondary succession gives the lake a second chance.
Ecosystems change every day in small ways. Nature and humans both cause changes that affect the ecosystem.
When those changes happen, they cause succession to take place. Succession is the gradual growth of new organisms in an environment. Sometimes a brand new ecosystem is born from the changes. That's called primary succession.
Other times, an ecosystem is wiped out by natural disasters or by humans. When it begins to regrow and start anew, that's secondary succession.
I was really pumped to do some fishing today. I'm sort of bummed.
Me too, but maybe we came for a reason. Let's make some changes and clean this lake up.
So, the study jam showed you exactly what succession is, and it showed you the two types. So, let's go over those again. So, sometimes a small community starts to grow in an area where there had been no other organisms previously living. And then over a very long time, a series of organisms live and die on the rock. It normally starts with lichens and moss. That rock is then slowly transformed into soil. So this process is primary succession because it's the first thing to ever grow there. So, for example, the fern at the very beginning, that would be primary succession. Here is another example. Each of these pictures show the same area, just over a long time period. So to begin with, we have a slowly retreating glacier that exposes bare rock, and there's nothing that lives there. So primary succession is beginning here. Here you see lichens, and then these acids from the lichens that you see on the rocks begin breaking the rock down into smaller particles. These particles then mix with the remains of the dead lichens, and it begins to form soil. Lichens would be an example of a pioneer species, or the first species to be there. And here is this area after many years. There's enough soil for mosses to grow. The mosses eventually replace the lichens. Insects and other tiny organisms begin to live there, and when they die, their remains add to the soil. Then over time, as the soil deepens, the mosses are replaced by ferns, and the ferns may slowly be replaced by grasses and wildflowers. If there's enough soil, you will have shrubs and small trees that will begin to grow. And then finally, after hundreds or even thousands of years, the soil may be deep and stable enough to support a whole forest. So from a retreating glacier all the way to a forest. And here is a video on just primary succession.
Ecosystems are shaped by biotic and abiotic factors. But before biotic factors like plants, animals, and fungi can become established, we need abiotic factors. like sunlight, rainfall, and nutrients. And today, I'm here with ecologist Joe Mascaro, and he studies how ecosystems change over time. And Joe's going to help us understand how we can start with solid rock, and through biotic and abiotic factors, they can change this rock to support life. So let's track the stages of primary succession by visiting lava flows of different ages.
So, Suze, this is the earliest stage of succession, where the rock's been colonized by lichen and some small sword ferns. These guys will colonize lava right away, almost the day after it cools. And once they do, they'll begin the soil formation process. So they'll grow and they'll start to break apart the edges of these rocks, which are really friable and easy to break. And then the lichen will fix nitrogen from the atmosphere, and that will begin to build up soil on the surface of the rock.
Now let's move to the next stage of succession, one that's a bit older.
Well, Suze, this flow looks like the ecosystem has developed a bit more than the last flow. So you can see how there's so much more lichen than there was in the previous flow. It's almost like a carpet. And as the lichen grows, it's basically breaking up the surface of the rock and starting the soil formation process, which is really happening in earnest now compared to the previous flow.
The first plants that become established are early colonizers. Early colonizers have other characteristics. They're fast-growing, they need lots of light, and they're usually wind-dispersed.
That's right. And there's basically two types of early colonizers we might see on a flow like this. There's some that have a symbiotic relationship with fungi, and so they're able to fix atmospheric nitrogen directly and use it immediately. And then there are plants that are just able to tolerate really low levels of nitrogen, like ohia.
Okay, off to the next stage. So here we have an even older flow.
So we're actually going to see quite a bit more soil here than we saw in earlier flows. And we've really got a lot of moss. So we're really starting to see the ohias come together, and we're getting much closer to a closed forest. We're not quite there yet, but you can see how much taller they are and thicker.
Off to the next flow. So this is what scientists would call mature forest. It's over 300 years old. It might be hard to imagine, but this whole area was once barren lava rock. Let's go check it out.
So we're definitely in a later successional forest now, which means we're dealing mostly with tree species that are not wind dispersed. They typically have big fruits, maybe dispersed by animals. They're much slower growing, and of course they tolerate shade. And as a result of all those features, they tend to need a lot more nutrients over time to grow.
All right, so that shows you an example of primary succession. Now we're going to move on to secondary succession, such as the forest fire. So if a community is disturbed in some type of way, whether that be volcano, fire, hurricane, or simply just by humans having a disaster of some sort, like an oil spill, if some of the soil is left intact, meaning if some of the soil is actually left there, the original community that was there may begin to regrow through a series of stages called secondary succession. So here is an example of secondary succession. In the first image, and just like before, each of these images is the same area. And yes, I know, in the second image, the barn and the silo have disappeared. I don't know what happened to them. Maybe someone tore them down. We're not worried about that right now. We're just worried about what's going on with plant life. So this would be the first year after a farmer stops growing crops, or the first year after some major disturbance, such as the fire or volcano. Weeds start to grow. If you've looked outside in your mom's flower bed, you know that weeds can grow pretty much anywhere. And they will do better than anything else that's growing there. In farming areas, crabgrass is the weed that often grows first. And then by the second year, you have new weeds that appear. Their seeds could have been blown into the field by the wind, or insects may have carried them. Horseweed is a common weed that you see during the second year. And then in 5 to 10 years, small conifer trees may start growing among all the weeds, and the trees continue to grow. And then after about 100 years or so, a forest may form. And then finally, as the old conifer trees die, they might be replaced by hardwoods such as oak and maple trees. That's if the climate can support them where they are. So this is an example of secondary succession. And now we're going to review that.
Hi, it's Mr. Anderson, and in this podcast, I'm going to talk about ecological succession. Succession is simply a series of events by which life comes back. And so what am I talking about? Well, look here, we've got a picture of a forest, but this is a year after there was a forest fire. And so you can see a lot of the charred, burnt trunks. And so basically, a photographer came here, and he came here once a year to the same place and took pictures. And so this would be year 1. This would be year 2. This would be year 3, year 4, and year 5. And so basically what you see is life coming back and changes taking place. And that is called succession. And it tends to occur at a predictable rate and using a number of predictable species. And so basically succession we could break into 2 different parts. The first one is called primary succession. Primary succession occurs when you have bare rock. In other words, when there's no soil left. And so if you look at this lava flow, basically the lava flowed down here. You could see they've kind of cut a footpath here. But basically life is starting to come back. Life can't grow out here for the most part because there's no soil there. We can't have plants that start to grow there. And so we have to have erosion, we have to have wind and rain, and eventually we have soil, and then we can start to have plants come back. Another example of primary succession is right here. This is a picture of Mount St. Helens the day before it exploded. After it exploded, it looked just like this. And so here in Montana, we had about that much ash everywhere. And that just came from the top of this mountain as it exploded. Well, this would be primary succession because there's no soil left. It's all gone. It's in Montana, not in Washington. And so basically life has to reestablish itself. And so this is a picture of Mount St. Helens now, a few years ago. And so this is on this on this rim up here. And so basically what's had to happen, a series of events by which life has come back. Now if you compare this to that Estonian forest, you can see that it's coming back slower. And that's because we had to go all the way down to the rock. Great example of this is the island of Surtsey. And so I think this was in 1962. All of a sudden off the coast of Iceland, there's a huge volcano and a brand new island shows up. They name it Surtsey, which is some Norse god. And so basically what scientists decided to do is to not go there. A few scientists will go there every year just basically to study how life comes back. And so you can see all this vegetation on this island, and there's been weathering going on. You would just think this is just a regular island, and it's really not that old. And so the cool thing is they can see what species are showing up first. It didn't take long for vascular plants to show up, and you might think, how did they get there? Well, a lot of them are blown by the wind or carried by birds or float there. And so it's pretty cool, but all of that again is primary succession. Secondary succession, and this is a gorgeous picture that was taken here in Montana during a forest fire. Secondary succession occurs when we have some kind of a disturbance, but the soil still remains. And actually the burning of fires is something that's really common in the mountains. And so you can see this elk here after the fires in Yellowstone Park, and there's no vegetation. But what you should know is that the soil is sitting there and life is ready to come back. And so basically this is what Yellowstone Park looked like a few years later and then looks like now. And so what were some of the first organisms to come in? Well, we tend to call these things pioneer organisms. And pioneer organisms are going to be organisms that tend to make their living by coming into an area after there's a disturbance. And so 2 examples in Montana. One would be lupin. Lupin is going to be a flower. It's actually a legume, so it's related to a pea. And what's nice about lupin is that it can fix nitrogen. It has bacteria that live on its roots, and they can actually take nitrogen in the air and return it to the soil. And then another example would be lodgepole pines. Lodgepole pines are really skinny and long conifer trees that we have here in Montana. And basically what they do is they have 2 different cones. They have certain cones that they use year to year to reproduce, but they also have these really waxy, what are called serotinous cones, and they're just filled with wax, and they never open unless there's a fire. And if there's a fire, then they'll open up and then their seeds will come back. And so basically lodgepole pine have evolved this niche, their way to be a pioneer species, to come in. Now eventually, as that forest starts to develop, it's going to be replaced by more climax species. And so that's another term that I just threw in there. That's called the climax. Climax is basically what's going to happen after succession. So on this side, we'll have a disturbance. So we're going to have a disturbance on this side. So what are some disturbances? We could have fire or human disturbances or like a tsunami. A really cool disturbance is after Chernobyl, the meltdown there, all humans had to leave, and so it's a wild kind of a land. But basically life can come back. And how does it come back? Well, let's look at this chart, which is great. So if we look at bare rock's going to be the first thing that you have, and the amount of bare rock is going to drop off as vegetation, of course, starts to come in. What's next? Well, then we're going to have mosses and grasses come. Why don't they come right away? Well, lots of times there's no soil there. And so we have to have weathering, rain, wind, and then we start to get soil, and then they can come back. Now you might think, well, why don't they just stay forever? Why don't they just have a huge amount of these grasses? Well, if you think about it, as other species start to take off, they're going to be taller than those grasses. They're going to start to take the sunlight, and so they're going to be replaced by other species, which is eventually we're going to have some small wooded plants, and then we're going to have some trees. This would be like the lodgepole pine, and eventually we have some trees that come back like that. And so what happens eventually, everything kind of levels off, and then we have these climax species at the end. Does it stay like that forever? Well, it depends on your size. So if you're like a redwood tree, you're big enough that fire sweeping through an area is not going to affect you. But most species are going to be killed by a disturbance, and then that whole process starts over again. And so what is succession? It's the series of steps by which life comes back. Remember, there's primary no soil, secondary soil, and I hope that's helpful.
So he gave a very good synopsis and some other interesting facts, such as Chernobyl. So he also mentioned mature communities, and this leads to biodiversity. So in the early stages of succession, we know that only a few species grow in an area. And then as he showed you on that graph, as a community matures, it may be dominated by well-adapted, slow-growing climax species. And anytime you have a big variety of species that are in an area, this is referred to as biodiversity. So remember, bio means life, and diversity means it's very diverse. There's a lot of stuff there. So a lot of life. Having biodiversity helps communities lessen the impact and spread of disturbances such as insect invasions. So mature communities tend to have biodiversity. And a mature community simply means it has organisms that are well adapted to live together in the same area over time. Okay, at this point, you're going to complete the Kahoot on ecological succession, and you will find that assignment in Google Classroom. You know to complete your directed reading 3.2, which is in page 8 on ecological succession, and then record your answers in Quizzes. Once you finish this, I want you to go to this link. It is an interactive game on succession, and when you finish it, there will be a prompt that will let you email your results to me. So if you would do that, I would appreciate it. And then finally, you are going to complete the story of succession activity. And you're going to find the explanation to this in Classroom. and this will not be due until Friday. So don't worry about completing it today. You've got several days to do this. But basically, I want you to create a story, your own story of a real world example of succession. You could use one that has already been given and expand on that idea a little bit. You can write this down as an essay. You could, and then draw a picture to illustrate it. You can maybe make a poster and then make a video and Flipgrid and explain what's going on in your story of succession. Or you can just come up with some other mode of instructional device that you want to use to show your story of succession. Be creative with that. If you're unsure of what to do, let me know and I will guide you through the process. Okay, this is the end of lesson 3.2 and chapter 3. Once you've finished your activities for today's lesson, I have included a few other videos at the end of this on Mount St. Helens and Yellowstone. And if you have time, you can go back and watch those videos. They're full of all types of knowledge. So I highly suggest you watch them if you have time once you've finished your activities. That concludes our lesson 3.2.